Now we're going to solve this problem. So let's take a look at what we have. Now the first thing that I hope you notice is that these terms are out of place. They don't have the highest power as our leading term, so we're going to need to move that term up to the front. Also notice that it's not set equal to 0, and we can't start solving this until we set it equal to 0. So let's go ahead and get those two issues resolved, and we can go from there. Now the first thing that I want to do is I'm going to take this positive 2x and I'm going to move it to the very front because my leading term should have the highest power. So I have 2x squared, and then I'm going to go ahead and bring down this negative 3x, and I have equals negative 6. So I'm going to bring that down as well. Now we're not done yet. In order for me to go ahead and solve this, I need to take this 6. I'm going to add it to both sides so I can move it over here on this side of the equation, on the left side, right? So that way it cancels over here. That becomes 0. And then now on the left, if I rewrite the whole thing, I end up with 2x squared minus 3x. And this is going to be basically 0, right, plus 6. So plus 6 equals 0. Now I'm ready to use the quadratic formula, right? We had to rearrange our terms and we had to set it equal to 0 before we can use the quadratic formula. And just remember that when we're using the quadratic formula, this first number in front of the x squared, that's my a, right? Because this is a x squared plus b x plus c. So just remember, right, the 2 is going to be my a value, the negative 3 is going to be my b value, and the 6 is going to be my c value, because we got to make sure we get the letters in the right place. So let's go ahead and let's write the quadratic formula. My quadratic formula is going to be negative b plus or minus the square root of b squared minus 4ac divided by 2a. Now we're going to replace these values one at a time. So I'm going to put negative, put some parentheses there, plus or minus the square root of my b, so I'm going to put parentheses, squared minus 4 times my a value times my c value, and this will all be divided by 2 times my a value. So we're going to start substituting numbers now. I'm going to do them one at a time. So for instance, for b, I'm going to go down here. My b value is negative 3. So I'm going to put a negative 3 in there. And this is another b. So in place of that b, I'll have parentheses and put another negative 3 inside. And then after the 4 is my a value. And if I go over to my problem, my a value is 2. So I'll put a 2 in there. And then my c value, right, the last one was 6. So I'll put a 6 in there. And then it says 2 times a, right, 2a. So for the a, it's going to be a 2. All right, so we got everything in for the quadratic formula. So now what we want to go ahead and do is we want to go ahead and start working this out. Now I'm going to go ahead and start by just distributing this negative sign. A negative times a negative makes a positive. So in this one I'm going to move a little faster than the last one. So that's going to become positive 3 plus or minus the square root of. And this one I'm going to go ahead and put this in the calculator. So what you see right here underneath the radical, right? I'm not going to put the radical in the calculator, but I'm going to put that in there because there's no point in doing that by hand. Calculator can do that for me and give me a value. So I'm going to go ahead and put it in. So parenthesis negative 3 close parenthesis squared, and then minus 4 times my a value of 2 times my c value of 6, and hit enter, and it gives me negative 39. So I'm going to put in here negative 39. And then this is all over 2 times 2. So 2 times 2 gives me 4. So all over 4. All right. So we got that part out of the way. And so now we're really just going to continue the process. I'm going to move my camera down just a little bit. And we're going to continue simplifying this answer. Now we do want to check and see, can negative 39, can that radical be simplified further? Now what I usually do when I'm doing a problem like this is I'll just rewrite it over here and see, can I break it down. Now I always try on my calculator. I like to use prime factorization to simplify my radicals, And some of these can't simplify, so this might not be able to be simplified. But we'll know if it can be simplified or not when we start breaking it down. So you can always start with a prime number like 2. Notice 2 doesn't go into it evenly, so then I can check the next number. So 39 divided by 3. And notice if 3 can go into it, it gives me a 3 and a 13. Now because I noticed that 3 and 13 are both prime numbers, I know that this cannot be simplified any further. Because in order to simplify it, I'd have to pull out a perfect square, or at least find 2 prime numbers that can, so that way they could be multiplied to themselves and we can remove it. In other words, if I had the square root of 3 times square root of 3, that turns into 3, and I can simplify the radical. In this case, neither one of these are the same number. I have 3 and I have 13, and there's no other factors for 13 other than 1 and 13. So at this point, I recognize that I cannot simplify this any further. So I'm going to circle it and just put a big X on it. So it is simplified as much as it could be. Simplified. Put a check by it. But I tested it before moving on. And so once I get to this point, I'm almost done. This actually becomes a pretty easy problem, because now all I got to do is get the negative sign out of the radical, right? And we know how to do that. So I'm going to do 3 plus or minus the square root of negative 1, right, which is me pulling out that negative sign from that radical, times the square root of 39. Now we have a positive square root of 39, which is good, and we got rid of this value right here, right? That square root of negative 1, it's sitting there. So I'm going to divide all this by 4, and remember that this square root of negative 1 really just turns into I. So I'm going to bring it down, and I'm going to put an I right there. So this becomes I. I'm just going to bring down the 3 plus or minus I, and then the square root of 39, I'll just bring that down because it can't be simplified any further, all over 4. And this is my final answer. So I end up with x is equal to 3 plus or minus I times the square root of 39 divided by 4. And that is my final answer. That is my complex solutions. One solution is 3 plus I times the square root of 39 divided by 4, and the other is 3 minus I square root of 39 divided by 4. But instead of writing 2 problems like I did in the last one, I'm just going to write 1 with the plus or minus, and anybody looking at this mathematically would understand this represents 2 complex solutions.